Welcome back to the Deep Dive. Today, we're focusing our attention on, well, on what it takes to move a massive amount of video data over a pretty significant distance. We're talking 20 meters.
Yeah.
We're going to be breaking down the technical blueprint of the PureLink TWH-8000F-200. It's an HDMI 2.1 fiber cable.
Right.
And the mission here is really to take all the jargon around this 8K high-performance stuff and, turn it into practical knowledge for you.
And that's really the core of it, isn't it? As soon as you push the HDMI 2.1 standard to its absolute limit, distance just becomes this immediate fundamental problem.
So you can't use a normal cable.
No, you just can't sustain that level of performance over 20 meters with traditional copper. The specs demand fiber optics. It's the only way.
Okay, so let's get into the headline numbers here. 48 gigabits per second. I mean, that's the maximum for the standard right now. How much headroom does that actually give a user?
Well, what that number gets you is the highest possible tier of uncompressed transmission. That capacity is precisely what guarantees you can deliver 8K resolution at 60 frames per second.
Sure.
Or, and this is critical for high-end gaming and post-production, 4K resolution at 120 frames per second. All of it over the full 20 meters with no data loss.
You just mentioned a key bit of jargon there. Uncompressed 4.4.4 color. Now, a lot of streaming services, they run on compressed signals, like 4.2.0. So who actually needs 4.4.4 as, like, an absolute requirement?
That's a great question. So 4.4.4 basically means every single pixel carries its own unique color information. There are no shortcuts, no subsampling to save bandwidth.
So maximum detail.
Maximum color accuracy. Think about broadcast facilities, medical imaging, or, a graphic designer trying to match a specific Pantone color. For them, 4.4.4 is perfection. Add in 12-bit color depth and HDR, and you see why you need all that bandwidth.
Right. And I guess when you're pushing 48 gigabits, the connection itself, it can't just rely on friction to stay plugged in. Which brings us to the build quality. Specifically, these SLS secure lock system connectors.
Oh, absolutely. The stability of the physical connection is just as important as the speed of the data. This SLS technology, it provides up to 15 pounds of retention force.
15 pounds. Just to keep an HDMI plug secure. That sounds like a lot.
It is. The contacts themselves are 24K gold-plated, and they sit inside this high-grade aluminum shell. It's all about durability.
So is that force just to guard against someone accidentally, tripping on the cable? Or is it something else?
It's both, really, but it's mainly to prevent what you could call micro-interruptions. With fiber, if the contact surfaces shift even a tiny, tiny amount from vibrations or the weight of the cable itself over time, you can lose the entire signal.
Yeah.
That 15 pounds just makes sure the connection is rock solid.
Okay, so beyond the physics, let's talk about the business side. For a pro installation, compliance is just as critical as bandwidth. The source notes, it's fully compliant with HDMI 2.1, has triple shielding for noise, and works with all the HDCP security standards.
Exactly. HDTCP compliance is table stakes, really. It means it can handle signals from older devices but still protect modern 4K and 8K licensed content.
Right.
But the other acronym in there that's crucial is TAA compliant. TA stands for the Trade Agreements Act. It's a government standard. And if you're installing equipment in, say, a federal facility, TAA is completely non-negotiable.
So to kind of wrap this all up for you listening, the key takeaway seems to be that this isn't just a cable. It's a complete solution that merges the highest data standard, 48 gigs over 20 meters, with some serious physical engineering, like that locking system.
Yes, and all the required professional standards like TAA and HDCP. It's about guaranteeing performance and stability where it absolutely cannot fail.
A mission-critical component.
And that really leaves you with a pretty interesting thought to chew on. If a single video cable needs gold-plated contacts, triple shielding, and 15 pounds of force just to hold it in place, what does that tell us about the future? About the massive infrastructural demands that 8K, VR, and whatever comes next are placing on all of our networking gear?
A good question. We're really getting to a point where speed and physical durability have to advance hand in hand.